In this tutorial video, we will demonstrate our deep learning detector with Classifier module. This module excels at identifying and optionally classifying various objects and defects under diverse and variable conditions. It is widely used for identifying faulty parts, verifying the presence or absence of components, and sorting products. To start training your dataset, you can either upload your images or capture them from the camera. In our example, we will show how to capture new images from the connected camera. In the top left corner, just under the PEKAT Vision logo, click on the camera icon to view the camera feed. To take your first image, click on the top right icon Capture. Move or rotate the screws to create variations in the images. Click Capture. To add the detector and classifier module, go to the top left menu and select the Modules option. Click Edit, then the plus button. Click the Detector option and click Add. Click Save Changes. To open the module, click at the newly created icon. Now you need to annotate all the objects or defects that you want the trained model to detect. To annotate an object, follow these steps. Place a rectangle over the object by positioning the cursor where you want the rectangle to start. Click and hold the left mouse button, then drag the cursor to cover the entire object or defect with the rectangle. Next, check the Classify option and click on the Class Manager to create classes for the objects. For our example, the first two classes will be Flathead and Hex. Click Save Changes. Select Flathead. To create the same class rectangle as before, double-click the left mouse button and move it over the object. Double-click again. Since we are annotating the hex screw, change the class to Hex. Adjust the size of the rectangle to fit the screw. Repeat the annotation process for the other hex screw. To add a new class, go to the Class Manager and click Add Class. Enter the name, Phillips in our case, and click Save Changes. Annotate the two Phillips screws. Adjust the rectangle. Repeat the process to create a class for Allen screws. Open the Class Manager, click Add Class, enter the class name, and click Save Changes. Annotate the two Allen screws. In the Class Manager, you can also change the color of the classes. Now, we will annotate the second image. Follow these steps, double-click to create the last used class rectangle for the first Allen screw, then repeat for the other Allen screw. Create a new rectangle over the hex screw and select Hex from the Annotation menu. Double-click to annotate the second hex screw. Create a new rectangle and select Phillips. Double-click to annotate the other Phillips screw. Create a new rectangle and select Flathead. Double-click to annotate the last screw and adjust the rectangle as needed. Now, using the slider, adjust the feature size. The feature size determines the smallest size of objects the model can recognize and sets the limit for annotation sizes. A smaller feature size allows the detection of smaller objects but requires more computational resources. Each side of the annotation rectangle must be larger than the individual squares of the feature size mesh. You will notice that the Phillips screw annotation rectangle appears darker when its size becomes smaller than the mesh squares, indicating that it is too small. Click Start Training to open the Training Options window. We will explore the individual settings in another video. For now, simply click Start Training again. The training process begins, and the training window opens. Here, you can view the selected options from the training settings, which are set to default in our case. You can also see the elapsed time since the training started and the ETA, estimated time remaining, until the training is complete. Since there are over 30 seconds remaining in the training process, we will fast forward to the next important part. Now, return to the camera view and check process to see the live processing. Replace some of the screws to check the results. All screws are classified correctly. Now we will set the inspection evaluation criteria. First, click Modules, turn off Live Processing, and select the Detector module. To set the evaluation criteria, click Evaluation. Here, we define the criteria that must be met for an image to be evaluated as OK. Choose either the and/or logical operator. Selecting and means all rules must be met, while selecting or means that only one of the rules needs to be satisfied for the image to be evaluated as OK. We will select OR. Next, click the plus rule icon to add the first rule. From the drop-down menu, select the first screw, flat head. Keep count as the criteria since we are interested in the total number. Retain the equal sign and enter 2. Repeat this process for all 4 screws. This means there need to be at least 2 screws of the same class in the image for it to be evaluated as OK. Click Save and Close. Return to the camera view and check process. Since there are 2 screws of at least one class, the evaluation criteria are met, and the camera feed appears in a green frame. Let's test again by removing one of the screws. We see that the camera feed incorrectly evaluates the hole where the screw was as an Allen screw. Capture the image. We need to readjust the confidence threshold. Go back to Modules, turn off Processing, and select the Detector module. Increase the threshold level to about 75%. Check the live camera feed. Returning to the camera view, we can now see only screws with confidence above 74.5%. Next, we want to set the evaluation criteria so that only images with 2 screws of each of all 4 classes are evaluated as OK. Go back to Modules. Click the Evaluation button. Change the logical operator from OR to AND, meaning all the rules must be true. Click Save and Close and return to the camera view. Click Process. The red image frame indicates that the image is correctly evaluated as not good. Place a flat head screw into the empty hole. The image remains evaluated as not good because not all the set rules are met. Once all rules, 2 screws of each class, are met, the image is evaluated as OK. The model is now ready for inspection. Thank you for watching. Try PEKAT Vision now. Visit us at www.pekatvision.com or contact us at sales@pekatvision.com.